All right, so yesterday we had talked about the even or odd degrees. So we also need to add to this about something called end behavior. And the end behavior is just what happens at both ends of the graph. So we're going to start off with, I'm going to circle these two guys here. So those are two polynomials that are even and positively oriented. So if we look back here, as this guy goes to negative infinity in our domain, y is going up forever. So that means y is going to positive infinity. Same thing here. As x gets more negative, y gets more positive. So we would describe that end behavior as x goes to negative infinity, y goes to positive infinity. So if we look at the other end of it to describe what happens as x goes to infinity, well, we'd say y goes to infinity. Same thing here. As x goes to infinity, y goes to infinity. So we would say that. So that's always the end behavior for an even, positively oriented degree polynomial. So now let's take a look at these two guys. Switch colors to make it easier. These two guys right here. So these are even degrees, but they have a negative orientation. So notice as x goes to negative infinity, y is going to negative infinity. Same thing right here. As x goes to negative infinity, y goes to negative infinity. So we would say as x goes to negative infinity, y goes to negative infinity. So if we look at the other side of it, well, as x is going to positive infinity, y is still going down, so negative infinity. And as x goes to positive infinity, y is going to negative infinity. So we'd say as x goes to positive infinity, y goes to negative infinity. So that would be the end behavior of any even degree polynomial that has a negative leading coefficient. All right, so now let's take a look at the odds. So your options with odds would be to have an odd degree polynomial that has a positive orientation, and that's these two general shapes here. So now we can maybe speed this up a little bit. So as x is going to negative infinity, y is going to negative infinity. Same thing down here. That's a negative infinity sign. And then when we look at the other side of it, well, as x goes to positive infinity, y is going to positive infinity. So as x is going to infinity, y is going to infinity. So notice, before the even degrees, they always ended in the same direction with the y values. I guess I should write y there. But these two are flip-flopped. This is negative infinity and positive infinity. So that's one of the characteristics of an odd degree polynomial. So now let's look at it when it's odd, going to negative infinity. So as it's going to negative infinity on x, y is going up. Same thing down here. So as x goes to negative infinity, y goes to infinity. So if we look at it as x is going to positive infinity, right, you guessed it, y is going to go to negative infinity because it's opening down. And the odd ones, these two should always be flip-flopped. So notice, as x goes to positive infinity, y goes to negative infinity. Same thing here. So that is the end behavior and how to express it algebraically class. But this is something else that we had spoke about yesterday. And I just want to make sure we understand how to find the general shape here. So if we look at A, we would say, well, what is the degree of that polynomial? So we add up the number of x's. We got 1, 2, 3. So this is has a degree of 3. Odd degree. Notice there's no negative sign out in front. So it is positively oriented. So we could just assume that A's general shape would look like this. Odd degree polynomial, positively oriented. Now we do the same thing for B. So we take a look at B. We got 1, 2, 3, 4 x's, so the degree of that is 4. And again, notice there's no negative there, so it's positively oriented. So we know that both ends, the end behavior, y is going to go to infinity. So this one we could just assume something like a W. So let's take a look at C. 1, 2, 3, 4. So our degree's 4 again, but notice this one has a negative in front of it. So that's telling us it's opening down. So it would look like the general shape of that. And D, remember if there's a square on there, we still have to count it twice. So we'd say 1, 2, 3, 4. So this tile has a degree of 4. And it's positively oriented. So it would look like we have a W again. Alright, E, we just counted the x's. 1, 2, 3, 4, 5. So it's odd degree polynomial. And it's positively oriented. So E would have a shape of something like this, maybe an extra hump or two in it. Again, we've talked about that in our previous video. So we should be able to find where these things cross the x-axis. So remember what a single root, and a double root, and a triple root are in order to graph them accurately. Alright, so I'm not going to, this is more for a class discussion. It's kind of hard to have a class discussion on here. But what I want to get across is whatever the degree is, that's how many solutions you should be able to find. So if you have a polynomial like this, you'd say, well, the degree of that's 5. So I know there has to be 5 solutions. Now, they could all be the same. You could have you could work it out and get 2 5 times. That counts as 5 solutions. Or there might be some imaginary or complex solutions in there as well that you would end up with I. But at most, it can have 5 real solutions. So that's just something to keep in mind as we work through this. Alright, so we're just going to try to state the minimum degree of each one of these. So it says, which of the graphs above show that x gets very large, y values continue to get large? So this is asking, as x goes to infinity, which ones have y going to infinity? So when you look at these, hopefully you're going to say, let's change these to make them a little bit. 1, 2, 3, and 4, so we don't get confused here. So notice as x is going to infinity on 1, so is y. So one of them. 2 isn't following that pattern, but 3, as x is getting bigger, so is y. So 1 and 3 have those characteristics. So B is asking, well, how would you describe the other two? Well, instead of writing it out in a sentence, we can just say, well, as x goes to infinity, what is y doing? Well, y is getting smaller in both of those, so we'd say y goes to negative infinity. And that would be how we express that. And we've already started discussing what positive and negative orientation are, so we should be able to describe this. So looking at number 1, switch colors again. This is a positive orientation because it follows that pattern. If it was negative, it would be flipped over. 2 is negatively oriented because it's opening down. It's an even degree polynomial, but it's opening down. 3, well, we got another even degree polynomial, but it's opening up. So that's positive oriented. So 4 is an odd because notice how each end shoots off in 2 different directions. And it's negatively oriented because it's been flipped over. So there would be a negative in front of that equation if we actually had one for it. And we've already started talking about single, double, and triple root. So looking at this one, notice that we have an x plus 5 squared. So that's telling us we have a double root. So that means with a double root, when it hits the x-axis, it shoots back off in the same direction it came from. So I just want to go ahead and just make this graph. Or, like I said, it's kind of hard to have a discussion with you guys over a video. So we're just going to talk about how we can graph this and make sure we understand what's going on. So this one, again, is a odd degree polynomial because if we add the number of x's, we got 1, 2, 3 x's. So our degree is 3. Like I said, we're not going to worry about having the discussion end up here. So that tells us, and it's positively oriented, there's no negative in front of it. So we know its general shape is going to look something like this. So now let's just go ahead and make a quick sketch of it so we have a good idea of what this thing looks like. So it looks like we're going to have to go back to negative 5, and we're going to have to go up to positive 2, because those are the 2 values that make it 0. So we put a dot at positive 2, and then we put a dot at negative 5. So notice at negative 5 we have that double root, and it needs to look like this general shape. So what we're going to do, since we're coming up to a double root here, we're going to hit it and then shoot back off in the same direction, and then cut back through, and we're done. And hopefully you're already thinking about what the end behavior is. As x goes to negative infinity, y is going to negative infinity. Now as we move x in the positive direction, as x goes to infinity, y goes to infinity. Again, we'll worry about how high and how low these graphs go here real soon. Alright, so this problem, I just want us to practice sketching them. So, pause the video right now and just take a minute and make a quick sketch of each one of these. And then I'm going to go through and do the same thing, and you can check your work along with me. So, let's take a look at this. So, A, we notice, is a third degree polynomial. Add up the x's and see that. And it's negatively oriented. So we know it's going to have a general shape like, I'll write it up by the problem, like this. Because that's what odd degree polynomials with negative orientation look like. So we're going to go through and find all the roots. So just an x means it crosses at 0. X plus 1 means negative 1 makes it 0, and x minus 3 means positive 3 makes it 0. So now that we have our three roots, we just want to make that shape like I drew up by A. So we're just going to try to cross through these points as nice and neatly as we can, and we are done. Now, we can describe the end behavior too. So I would ask you to look back at the previous slide and realize that as x goes to negative infinity, y goes to infinity. And over here, as x goes to infinity, y goes to negative infinity. So that's the end behavior for that polynomial. All right, so B. B, same thing. We're going to go through and find all the roots and make it 0. So we have a root of positive 1. That's a double root. So I'm going to put a little d down there so I don't forget. Then we have a single root at x plus 2, which is negative 2. And then we have another root at positive 4, because 4 makes x minus 4 0. So the degree of this guy is 1, 2, 3, 4. And it's positively oriented. So we know it's positive. So now, all we have to do is say, well, I know a positively oriented even degree polynomial is opening up on both ends. So now we're just going to try to draw that. So I know I'm going to start up here, cut through it, and then I have a double root here, so I have to hit it and shoot back off, and then I cross through again. And for our end behavior over here, as x goes to negative infinity, y goes to positive infinity. And as x goes to positive infinity, y goes to negative infinity. All right, last one. Notice we have a triple. Well, let's go ahead and say the degree. The degree of this one is, we got 3 x's, and then another 4. So the degree of this is 4. It's positively oriented, so it has the same shape as the previous problem, like that. So I'm going to go through and mark my roots down. So this one crosses at negative 2, and we got a triple root there. So I'll put a little t there to remind me that's a triple root. And then we have a root at positive 4. So remember, the triple root, we have to kind of wiggle through the x-axis. So I'm just going to draw it, wiggle through the x-axis, and then cross back over at positive 4. And the end behavior for this one would be the exact same as what's on C. So hopefully this makes sense, because we are going to start going a little more in depth with these types of problems. And again, there's just some information about roots and zeros and